Dear friends, we are into the next topic of the subject data structure. Having seen arrays and linked list as data structure models, we are going to the next sets of data structure models, basically stack and queues. So let's have a look at stack as a data structure. We know a stack by its meaning, nothing but a sequence of items ordered in a linear fashion. Mostly we understand one top of the other. So for a standard definition, it's nothing but a linear list of items where all the operations of insertion and deletion are performed only at one end of this list. Hence, when an insertion is done, the stack grows at one end, and reversely, if items are deleted, the shrinks at the same end. In order to represent a stack, we can have a static representation using arrays, or we can also have a dynamic representation using the linked list concept. Let's have a look at how an stack is implemented. So here is a stack of items. So we have items getting inserted at one end, the top of the stack. Also, we have items that are removed at the same end. So items are inserted, items are removed at the same end. So as we said, when items are inserted, the stack grows. When items are removed, the stack shrinks at the same end. In order to mark the position in the stack, we use a pointer called top, a marker, a pointer, which marks the topmost item in the stack. That is where insertion or deletion takes place. So conventionally, the two operations of insertion is referred to as push and deletion is referred to as pop. So let's have a look how items get inserted or deleted or pushed or popped from a stack. So when I push an item, let's say I'm going to push an item called X. I want to push an item X into the stack. So in order to push the item X into the stack, first I need to move my pointer to the next position so that I can get an item inserted there. So I insert an item. Let's say I want to get an item here. So I have top equal to top plus 1. Then I push the item. So the item gets inserted in the next position. And reversely, when I want to pop an item, what I do, I remove an item. Let's say I want to pop out the item X. Then I remove pop X. Then the top has to become one less. Top has to be decremented. It has to bring down to the next position. So it becomes top minus 1. So have a look at these two steps that take place here. So when a push operation takes place, what happens? Push operation, we have top incremented first to the next position, then I insert the item, and reversely when a pop operation takes place, I take out the item, then I decrement the top. There is a point of confusion here. Sometimes students mistake between the two. So push, we increment first, pop, we decrement after removing the item. The organization of data, insertion, organization, and deletion takes place based on the principle of last in, first out. When we look at stack, we know these are the properties. It's a linear item. We can implement either dynamically or statically, and operation is based on last in, first out. Basic operations possible are push, pop, and traverse. Traverse means I'm able to look through all the items starting from top to below the bottom of the stack. Now we need to be also aware other operations that are possible here is to check whether the stack is full or empty or initialize a stack. When is a stack empty? A usual custom is to keep the pointer -1 when we implement as an array so that first item gets inserted to 0, and when the stack becomes full, when it is equal to max, the size of the stack. So I know when a stack is empty, when it is -1. If the stack is empty, I cannot pop. If the stack is full, I cannot push. Those are the operations possible. Now let us see how we can implement the two. Having studied arrays, having studied linked list, we should be able to implement the same easily. So here is an implementation of an array. Have an array of size max defined, then top, let it be the index of the array. So I want to insert an item. Top is initialized first as -1. First item plus goes here till it reaches max. Then I know it is full, and I'm able to pop as long as the stack is not empty. I'm able to push as long as stack is not full, and I can check it by checking the value of top either or. So keep two flags called full and empty, and those values keep changing based on the position of the top. So that is implementation using an array. Coming to a linked list, let's imagine this is a stack of items implemented just as like a linked list. Of we have put the picture reversely or in a vertical manner. So we have the first item, second, third, and top is nothing but a pointer to a node item. So this is a node which has got elements. So initially the top would point to a null. First item, let's say 1, the top points the first item. Next item, top points here. Next item, top points here. So I can keep on inserting items as long as I have, being a dynamic representation, I have memory. Anytime memory becomes full, my stack is full too. To delete an item, nothing but, suppose I want to delete or pop this item, I remove this item and move my pointer down to the next. So if you look carefully, we understand insertion is nothing but, suppose I want to insert an item here, let's say 4, it's nothing but inserting a new node to the beginning of the list. And when I want to remove an item, I'm removing a first item from the top of a linked list. So insertion is nothing but adding an item at the beginning of a list, which we have done. Deletion is nothing but removing the first item in a linked list. So when I add an item, what I need to do, my top needs to come here. I need to link this. We have done this. Reversely, when I delete, what I need to do, when I delete an item, let's say I delete the item 3, sorry, I delete 3, then I need to move my pointer down. That's nothing but to the next node. So these two operations we have already done. So having done this, we understand the basic operation of a linked list as dynamically done on a stack and also as a static representation using arrays. So as a practical, it would be nice to do as a menu driven program which allows the following operation of push, pop and traverse and an exit option. So at any time when I want to insert an item to the stack, I can push. When anytime I want to delete, I can pop. Anytime I can traverse and see the items and come out. I think it's clear. Thank you.